Okay, let's just jump right into this explainer and uncover a hidden thief on your factory floor that's quite frankly silently stealing your time and money. When we think about manufacturing inefficiencies, our minds usually jump straight to the obvious stuff, right? Broken machines, blaring alarms, bins full of scrapped parts. But there is a much more subtle drain on your resources happening right in front of you, literally every single day. We are talking about the physical movement of your materials. And it's incredibly easy to become completely blind to this specific waste because, well, on the surface, it looks like normal, healthy factory activity. You see a forklift buzzing by with a heavy pallet, and you naturally think, great, work is getting done. But is it really? Let's find out.
Lean manufacturing is a massive topic, but today we're putting on blinders to maximize our focus. We're going to cover 1. The hidden waste, transportation. 2. The true cost of movement. 3. Redesigning the plant layout. 4. The cellular manufacturing solution. And 5. Flowcharts and continuous flow. So by the end of this, you'll have concrete layout solutions you can use to immediately fix inefficiencies on your floor.
Section 1. The hidden waste, transportation. Let's kick things off by looking at the core problem of moving parts. Because, to fix a problem, we first have to actually see it clearly. So, I really want you to ask yourself a serious question about your operations. Are your components actually working, or are they just acting like tourists taking an expensive meandering trip across your warehouse? I know, it's a funny image, but it's incredibly accurate and honestly a bit alarming when you look closely. Just imagine a piece of steel bar stock. It arrives at the dock, gets unloaded, and sits in receiving for 2 whole days. Then a forklift takes it 500 feet across the facility to the cutting department where it sits in another queue. It gets cut, sits again, and then someone with a hand cart hauls it all the way to the CNC machines on the total opposite end of the building. Guys, it is collecting stamps in its passport, not adding value. When raw material enters your facility, every single inch it travels should ideally be pushing it toward completion.
In the Lean philosophy, this grand tour around the facility is officially classified as a massive inefficiency. Out of the famous 8 wastes of lean manufacturing, which you might know by the acronym TIMWOODS, transportation is wastage number 5. It's specifically defined as the unnecessary movement of parts, materials, or finished goods into or out of storage or between processes. Basically, any handling or transfer of materials that doesn't directly add value to the product from the customer's perspective, that is absolute waste. And the reason this specific waste is so often tolerated or just completely ignored by management is that moving things feels absolutely necessary. We just kind of accept it as an inevitable overhead of doing business, rather than seeing it for what it is, a highly solvable defect in our layout.
Moving on to Section 2, the true cost of movement. Now let's explore why this invisible waste is so incredibly damaging to productivity.
Transportation is a really insidious trap because movement actively feels like real work. Factory managers frequently walk a production floor. They see forklifts zooming around, watch operators bustling from one end of the shop to the other carrying bins, and the factory just feels busy. That busyness psychologically translates to feeling productive. But actually, scratch that, it's a complete mirage. You are simply watching overhead costs burn in real time. This movement only increases your manufacturing lead time and your expenses. Think about it. Your customer is not paying you to transport materials back and forth around your own facility. They are paying for a finished product. Activity absolutely does not always equal achievement.
And the cascading negative effects of this unnecessary movement become painfully clear once you strip away that illusion of productivity. First off, pushing carts and carrying bins causes severe, chronic operator fatigue. It also requires fleets of extra material handling equipment which, as we all know, inevitably suffers expensive wear and tear. But worse than all of that, when a part travels, basically only 3 things can happen. It arrives perfectly, it ends up in the absolute wrong place, or it gets dropped and damaged in transit, requiring expensive rework or scrap. So 2 of those 3 guaranteed outcomes are terrible for your bottom line. And meanwhile, your downstream processes are just sitting there completely starved, waiting for those parts to finally show up.
So our first primary control strategy to fix this is to redesign the plant layout using what we call a spaghetti diagram to actively minimize that travel distance. If you take a floor plan of your facility, pick just a single product and literally draw a line following its physical path from start to finish, you end up exposing absolute chaos. This happens in a traditional process layout or job shop where all similar machines, like say all the lathes in one corner or all the mills in another, are clustered together in isolated departments. To make just one single part, the material has to zigzag wildly back and forth across the entire building, creating this tangled, super expensive web of wasted time and effort.
Section 3. Redesigning the plant layout. We have got to definitively untangle this spaghetti and move aggressively into the solution phase.
The contrast in strategies here is pretty stark. To eliminate this waste, we must fundamentally rethink how we arrange our equipment and completely abandon that traditional process layout, where parts travel miles between isolated departments. Instead, our next crucial control strategy is to execute a cellular layout. This means we mandate that sequential operations are placed physically adjacent to one another. Just think about it. Instead of having your raw material cut at the front of the shop, loaded onto a pallet, and driven a quarter mile to the drilling department in the back, you physically pick up that drill press and move it right next to the cutting saw. Instead of moving miles, parts move mere inches, passing directly from hand to hand. It's a total game changer.
Which brings us to Section 4, the cellular manufacturing solution. Let's look at exactly how cellular manufacturing solves this travel problem in daily practice. In a streamlined cellular layout, the operations are physically linked. To achieve this, you first have to identify your product families. Basically, look closely at your catalog and group products that share similar processing steps. If product A and product B both require cutting, then turning, then polishing, boom, they belong in a family. Once you define a family, you create a dedicated linked manufacturing cell for it. The raw material comes in and it moves seamlessly from machine to machine in a continuous, highly logical flow until it's finished. You are bringing the required tools directly to the product rather than sending the product on a never-ending tour to visit the tools. And the ultimate physical expression of this concept? That's the U-shaped work cell. The fundamental goal of a lean work cell is to remove absolutely all non-value-added physical movement. By organizing the sequential stations into a tight U, the physical ergonomics for the worker improve dramatically. I mean, instead of walking 20 feet down a long, straight assembly line to hand off a part, an employee working inside a U-cell can finish an operation, simply turn 180 degrees on their heel, and place the workpiece at the very next station. Turning is drastically faster than walking, and it immensely reduces physical exhaustion by the end of a shift. Plus, it entirely eliminates the need to constantly pile up and transport large batches of inventory.
Section 5. Flowcharts and continuous flow. Finally, let's break down the specific resource tools you need to actually implement this continuous flow on your shop floor.
Real transformation absolutely does not happen by guessing. It requires a structured approach. So treat this as your definitive checklist to take back to your facility. Step 1, you must map your current state, using logistics flowcharts to truly understand the stark reality of what's happening today. Step 2, you draw those spaghetti diagrams we talked about to make the chaotic, wasteful movement visually undeniable to your management and your floor team. Step 3, execute the control strategy. Break up those old entrenched departments and physically unbolt and move sequential operations right next to each other. And finally, Step 4, refine those adjacent stations into highly efficient U-shaped work cells. To support this transition, you really need to leverage essential resource tools like cellular manufacturing designs and logistics flowcharts. You can also utilize value stream mapping to formally identify all those activities that just don't add value. And, when it comes to the physical movement within the cell itself, lean design heavily favors incredibly clever, low-tech solutions. You don't always need million-dollar robotic arms or motorized belts. You can install simple gravity-feed manual push conveyors. They require zero electricity, zero complex maintenance, and honestly, they just don't break down. And for those tricky, tight corners in a U-shaped cell, you can drop in ball roller transfers so heavy parts literally just glide right through the turn without requiring any lifting.
Now, listen closely to this foundational truth because it perfectly captures the absolute essence of lean manufacturing. Every single time a part is picked up, put onto a cart, driven across the building, and set back down again, you are actively burning cash. You are paying for hourly labor, for equipment wear, and for time. But the product itself, it hasn't improved a single bit in quality or readiness. Like we said earlier, if the customer isn't paying for the part to take a grand scenic tour of your factory, you absolutely shouldn't be paying for it either.
So I want to leave you with this final thought to really challenge your perspective. Tomorrow, when you walk out onto your production floor, don't just look at the machines running. Watch the materials. Pick a single part and follow it from the precise moment it enters to the moment it finally leaves. Are your parts actually being processed and having value added, or are they just traveling? Find that hidden thief of transportation waste, utilize your resource tools, build yourselves, and aggressively reclaim your efficiency.